Hello everyone, thank you much for coming here and let's get right into the video. So we are basically exploring today with Grasshopper the idea of having a form that you have in the Rhino geometry and you can manipulate and change in the Grasshopper environment. For example, you see you can add and remove, like depending on points, walls. And you can also change the walls that you have accordingly, also with a certain roof that is built on top of that. So we are using a few commands here, also the one with pipelines, to get you closer to that. So let's just start with a very new file, and I will more or less show you how this, or I will show you how this will be done. So we are having just those polylines that we have to define before, and those will be manipulated. First of all, we're going to use the command pipeline, and it's Geometry Pipeline, and here it gives us certain options that we can use. The first one being the layer, the name, this is irrelevant, but also the type. So we want basically all the types of those curves in here that we are drawing. However, we first have to create a layer that is basically corresponding to that. So I already created a walls layer and a doors layer. On the walls there will be the walls defined, and on the doors are the points that are used for the doors that we define. So we are having the layer name here would be double click on it, and then you type in walls, and then you also click this button here, double, and you see it imports those things. And this one is also on the wrong layer, and you see it is not in the correct one. So you're just gonna click on it, click here, put it on the walls layer, and you see it gets incorporated as well in this seconds. So that's pretty great, and we're going to just copy and paste the same, and we just rename the walls layer and to doors, and we put in the type of points and deactivate the kind of the curves. So now we see we have those points in there as well, and if I move them around, it updates automatically. So that's pretty well, and you can also obviously if we add lines as well, you will see it gets added to it as well automatically without having to re-import them. So that's already pretty good, and we also want them to do certain things, obviously. For example, we have those walls here, and we want them to span a roof on top of it. And we also want to do this only for the ones that are closed. So those ones are just like hanging out for now, but those will be basically have to be all connected. So we are first going to do the region union, for example, which takes those things and puts it together. However, we're getting an error because the curves that it can use are it's only possible with closed poly curves. So we are going to have to use the we have to test if the curve is closed or not. So we're just gonna use closed, like is closed, or just closed, and we're gonna use this curve as the input, and the output would show us if it's true or not. And you see this is true, false, blah blah, and we want to get those curves out of here. So this is the pattern basically that we are having from the beginning. So we're going to use the dispatch command, and from the closed curves will be the dispatch of the curves we import in the beginning, and those then will give us the curves that are actually closed. So let me just try with this one, and yes, this already looks pretty good. You see it makes a very nice out ring of it. So this works already pretty well. I really like to see that it's working like this. And we also can use a boundary surface then here, and you see it gives us a very nice door, like slabs from in the bottom that we want to basically walk on. So that's already pretty nice and defined. And now we also want to define a certain wall thickness as well. So we're just going to use the command offset, and we're going to offset it once to the outside and one time to the inside, so it gets a certain thickness into both directions. And we're going to use the geometry pipeline of the walls layer. And then we also are needing to use a number, so I just double click and just type a number like 2.00, and we type this with thickness. And this will then be the thickness, but we also want it from the other side as well. So we're going to use another offset curve, and this one will be, however, in the negative from the thickness. So you see now it will be from both sides. Right now it's double the thickness. We can also do a division. Actually, let's do that. So we divide the thing by 2. So right now, it's, for example, at 1, the problem would be that the thing would be now 2.10 long, thick, instead of 1.5, because it gets to both sides. So we're just gonna divide it by 2, put this in here, and we're just gonna reconnect those things to there, so there's no confusion about what this thickness here means. So that's pretty good already. And we also now want, we have to also we have to see if the curve is closed or not, because if they are closed, we need to basically stitch them together and make sure they're closed, because the offset only works for those closed curves, because it is a closed curve and it ends where it starts, but here it doesn't end where it starts. So we want to close those two things together. So we're gonna first merge those curves here, and then we need to test if they are closed or not, actually. And it gives us again a panel, or it gives us a result if they are closed or not. And as you see, some of them are, some of them are not. Or we can actually could use the same one, but whatever. Anyway, and now with those ones, we need to basically define, close those ones off. So we're going to use a dispatch again of those curves here. And this time the dispatch will most likely be the second one. Let me just put a geometry one here. Yeah, as you see, it only now gives us only those closed curves. However, for example, if we continue this curve and we press in C and enter, so it closed the curve, you see it would disappear from the list that we have here, and it would automatically jump to and close itself, how we had it here. So we're going to do this by doing just a very small like input-output thing. We are going to use the endpoints of those things here, and then we are using a polyline, and those should connect those two things together, if I'm not mistaken. Yes. Ignore the orange warning, it's not that bad, it's fine for this case. And now we have our defined polylines, and now we have to join those two curves together as well. So we have the beginning curves, and then we have the those small polyline thingies that get connected, and they should be forming a curve now. Let me see if that works. Yeah, this looks all very correct, and it gives us all those curves, it looks like. Oh yeah, this one is orange because some of those dispatched ones are empty lists, so we but that's not a big deal for the moment. And we can actually just pack those things up as well, like this, and we're gonna middle click mouse button and then click this cluster option, and it will just make this very nice and tidy. So that's pretty good already. And now that we have those defined, we also want to define if the curves that we had here in the beginning, if they basically if they are actually in the correct position. There's actually one more thing that I could maybe try to do now, which would be if they are closed. And is there a command like that? There actually would be a way of making this even more interesting how we had before, because before those things were not connected together. So I want to actually connect them together now. Let me just very quickly try that out. So we have the curves here, and if they are closed off, they are those curves. So we use the endpoints of those curves and put a line in between those two. And yeah, you see it will now connect this curve together, but I just want to have it as a roof. It's just, this is only for the ones that are open. So we just want to close those off on the roof, but leave it open as the wall. So basically it's just like the roof pattern that goes up on top of there. So we're going to use that, and we're going to join them together as well, like this. And this should result in those curves. And I think if I just, okay, this doesn't correctly work. Ah yeah, but I think it makes some trouble if you have those curves, as you see, that are just going out like that. It doesn't know where to connect in this part, however. But I think we can still just dispatch them out as well. So we just check again if they are closed or not, and it gives us the same result. And then we're gonna dispatch those depending on those results as well. And let's 1, 2, 3, 4, 5. Okay, if I just let me test. Okay, it will close those one automatically. Yes. Okay. And those then will be the results will be this poly curve here, which we are going with shift click add it to this one here as well. And we're just gonna also flatten this layer so it's gonna be correctly implemented. So very nice. So we had actually solved one thing that I wanted to solve before, but it actually came into my mind while I was doing this. That's pretty good. So kind of like real life, in the moment programming, or grasshoppering, however you want to call it. Anyway, let's get back to our walls here that we have, and that are just like going out a little bit. So we have those now defined already, and I want to basically now define, or I basically want to put those two together. This is like a bit sketchy now, I would say, but we take the points that we had here in the beginning and those ones as well. So this will basically be our walls. However, the problem at the moment would be that they are not intersecting. Actually, that's not that bad, to be honest. We can just extrude them anyway. Let me just take a look. So in a Z direction, and then we put a number slider in here as well. Now let's just see if they will be just extruded normally. And then we have our extruded curve. It's a little small, but that's fine. Actually works pretty well. I wanted to have it before so that they are actually basically fused together here like this. This could be possible by another method, but for now I don't think we need it actually. Okay, anyway, I want to, works pretty well for now, but I also want to introduce two more things. One being the points that we defined here before that are acting as like a certain wall, or like like a door, and with that we need to use the following. So we have basically those curves here at the beginning, right? Okay, I basically want to cut them open. So I can do this by using the command under region, and it would be, let me actually take a look. Yeah, at intersect region, and then we go trim with regions. So we're going to use the curves that we had here in the beginning and use those points as like a circle, and it basically cuts them off. So this would be working like this. You basically have the thing, and then you would have a point defined here, and this point has a certain radius like this, and then it will basically cut those things off. So then this part here is not existent anymore, and it will be acting as a door in that sense. And it will go through the same process of seeing is it closed or not, and then it will just like close it. So we're going to define this circle around here, and we also give it like a certain number as well, obviously, a certain thing, so we can adjust it. And this will be then our region that we're gonna get cut off, and we need to also define if it's outside or inside, and I think it needs to be outside in our case. Yes, this already looks exactly how I wanted it to look. You see, we can just move them around, and if I would just change the layer quickly to our doors layer, we can put some points in here, and as you see, it will create our doors just by itself, which is pretty useful. Nice. And everywhere when I have the door, it creates this very nice thing. So we could make the door itself as well, but like, let's just see how far we are getting here for now. Yeah, I think this works pretty nicely. Okay, very good. Let's go back to the script. And we also want to define a roof, which in this case would actually be a little bit bigger, and the inner side needs to be a little bit smaller, so it would be not like in the middle but like there. So let's just offset this as well, and we offset it by the amount that we had defined here earlier. You see, like this, it just got a little bit more inside, so this will be put on there. And we also want to have this one as well, but it needs to be on the outside as a way of like finishing the roof. So we're going to just copy this, and we are going to use the negative amount of it as the curve. You see, it's already lined up there pretty nice, and we want to move it upwards from the point as much as those other walls are moved upwards as well. So we're just going to use the vector unit of z there, and we're going to move it here, and we also are going to give it a boundary surface. So this already looks exactly how we want to have it, and it gives us those very nice areas where we have some kind of overlap. So that's pretty nice. Now I want to clean up this a little bit so we can see a little more what's going on. Just gonna hide those things here, hide that as well. And now we have already pretty well defined like that. Okay, I'm already quite happy with the result for now. And now I also want to create a correct, let's say, door in this sense as well. So we have our region that we trim something with here, right? And maybe we can make this even a little bit more interesting, but I think, let's see if this will gonna work out. I don't know if, because I want to define from this beginning point and the end point, and I don't know if what it would do in a situation like those. Let's just try it out. So we're just gonna define the endpoints here, and then we're gonna put a line through that as well, like this. Okay, and then we're gonna extrude it upwards as well in this case, in the same amount how we extruded this one up here. And you see, okay, here it gives us actually quite so this one kind of works, but here it would be a little bit weird. Ah yeah, okay, I think this could be a little bit problematic, as you see, but it still kind of makes it a little bit of interesting, more connection in those places as well. I think it still kind of works. You have to like work around there, like maybe manually adjust it as well, but maybe that's a topic for like another video. Anyway, I also want to for now the roof is just kind of this very normal thickness, and I kind of want to give it some like it doesn't need to shouldn't be paper thin, so I want to give it some thickness. So we do this by offset curve or offset surface here, and we're going to use this as our offset, and we also want to obviously give it some sort of thickness, so we're gonna use a number slider as well. Okay, might need to be negative. That's sometimes because the surface is like turned upside down. And we also want to connect them together, and I think we can do this by just simply doing an extrusion again from this boundary surface, and the direction would be a Z direction again as well. However, it will be a positive. It should be the negative of the negative direction, so positive again, of our extruded surface. So here we would create it like that, as you see. And I think we could even maybe, because right now the surface is kind of bland, so I want to create this one. This works fine, but I want to make it a little bit that it goes a little bit more outwards as well. So I want to add to the distance just like a small number slider, and this distance, okay, it goes from negative, so maybe we also need to have a negative amount here as well. So yeah, very nice. So now it goes over a little bit, so it has some, can almost like stand under it as well. So that's pretty cool. Yeah, great. So now we can obviously I want to merge the things together that I want to bake. So this one goes with that one, goes with that one, and those ones are more like individual pieces. So I'm gonna bake this one, and I just put this on this layer, and this one on another layer. Group it, and the last one will be on another layer as well. I think I actually need to still do the doors. Yeah. Group, yes. And yeah, this looks pretty promising already. And the cool thing is, if you go now to the rendered view as well, and we're just gonna deactivate the view in Rhino, we can also now give those things some certain colors and materials, like, I don't know, this one would be blue and this one would be like a little more like grayish, and now we have those things really nicely defined, and you can make a very big area in a really like short time and define those entrances and things pretty quickly. And again, obviously you can just like go back in the Grasshopper geometry and change the things, and then you just rebake it, and it's very easy to do. So yeah, I'm gonna clean this up a little bit, for example like here, and we give this like the height, and we're gonna get this is the overhang, right? And we're also going to the thickness we have, and do the door size like this. And it's like always like good measure as well to kind of like make things a little bit more clean or more defined, so they don't get like too confusing at times, you know. So just wanna clean this up very quickly. But this is actually already it, kind of. And thank you very much for watching. And I will upload. Yeah, this will be uploaded on on the GitHub link that you will see in the description below. So you can just go in there and just download from there. It's very easy. It should be from today's date, so the 5th of May, and you can very easily just import it from there. And from then you can just use it yourself, or learn it again, or if you made a mistake and you don't know what it is, it should be there as well. So thank you much for watching. See you next one, and have a beautiful time.